Latvian Maritime Academy, Riga. Bridge Resource Management Course. Situational Awareness. Case Study. Grounding of 173.50 meters length and 32,396 gross tonnage cruise vessel Royal Majesty on June 10, 1995. There are days that reaffirm one's decision to go to sea. The sun glitters off a dappled blue surface. The ship proceeds smoothly, slicing its way through the water, the bow wave slicing off to the side and the wake making a creamy trail astern. Such days are often found in New England waters in the summer. The bright sun is moderated by a cool breeze, and, late in the day, the ocean turns from blue to gold as the sun sets. Even when there is overcast, daylight gives the sea a silvery sheen. Such were the conditions on June 10, 1995, as the passenger ship Royal Majesty headed for Boston from Bermuda on a north-northwesterly course. The visibility was more than 10 miles and the winds 10 to 15 knots. The ship was proceeding at full speed, about 19 knots, and the first 28 hours of the voyage had been uneventful. All the navigation gear had been tested and found satisfactory prior to departure from Bermuda. This was important because Royal Majesty had an integrated bridge system. This system consisted of a number of interrelated components, but the net result was that by electronically connecting the ship's global positioning system, GPS, receiver, autopilot, and an installed electronic map overlay on the radar, the ship could effectively take itself from Bermuda to Boston. The navigator simply entered waypoints in the map overlay, and the system, by comparing the GPS-derived positions with the intended waypoints, ordered changes to the course being steered by the autopilot. All the watchstanders had to do was make sure the system was functioning correctly. The captain and crew of Royal Majesty, however, went one step better. While the ship was sailing in open waters, they would plot the ship's position once per hour using the tried and true system of pencil on paper. Comparing the hand-plotted GPS position with the electronic charted position gave them, they believed, not just an accurate indication of where they were but also a good check on the performance of the integrated system. Also, even if the GPS failed altogether, they still had a long-range radio navigation, LORAN, receiver, which they could use to fix the ship's position. At about 16:45 hours, the captain called the watch officer and asked him when the ship would approach the BA buoy, the first of a series of buoys marking the center line of the northbound traffic lanes toward Boston that lie east of Nantucket and Cape Cod. The chief mate, on the watch, replied that the buoy should appear at about 19:15 hours. Sure enough, 2 hours later, the chief mate sighted a small radar contact on his port bow at about 7 miles. 35 minutes after that, the buoy passed down the Royal Majesty's port side at about 1.5 miles. The chief mate could not positively identify the buoy's marking as the ship passed. The buoy was in the glare from the setting sun. But it was the correct type of buoy, and its position coordinated almost perfectly with buoy bow's position as indicated on the radar chart overlay. In other words, the paper-plotted GPS positions, the radar chart overlay, and the sighting of the buoy all matched. 10 minutes later, the captain called asking about buoy BA, and the chief mate told him they had passed it. The second mate relieved the chief mate just about then, and the watch relief proceeded with the usual discussions about traffic, course, speed, and position. All seemed well, and the only change the second mate made was to adjust the radar range scale from 12 miles to 6 miles. The next buoy in the traffic scheme, BB, should have been about 25 miles ahead, which meant it would be sighted at around 21:15 hours. At 20:30 hours, the lookout on the port wing told the second mate that he saw a yellow light off the port side. There should have been nothing off the port side. The second mate acknowledged the report but took no action. Shortly thereafter, both the port and starboard lookouts reported seeing several high red lights on the port side. There still should have been nothing off the port side. The second mate took no action. Then the captain appeared on the bridge, checked the ship's position on both the paper and electronic displays, talked with the second mate, and went below. Everything looked correct to him. No one told him about the red and yellow lights on the port side. The Royal Majesty was not alone on the sea. 2 fishing boats with Portuguese-speaking crews saw her. They tried to call her in English on Channel 16 but got no reply. The 2 boats discussed the out-of-place cruise liner. Just over an hour later, at about 21:45 hours, the captain phoned the wheelhouse and asked the second mate if he had sighted buoy BB. The second mate told the captain he had, but in fact he had not. 15 minutes later, the captain went to the bridge again, checked the paper and electronic displays again, and asked the second mate again if he had sighted buoy BB. And again, for the second time, the second mate said he had sighted the buoy. He still had not seen it. The captain went below after about 10 minutes. Within a few minutes, one of the lookouts reported to the second mate that he saw blue and white water dead ahead. Because it was now at 22:10 hours, and therefore quite dark, the sighting must have been very noticeable. The second mate took no action. 10 minutes later, the ship veered hard to port, then hard to starboard, and began to heel to port. The captain felt the heel and rushed to the bridge. When he switched the radar up to the 12-mile scale, he found that Nantucket, which should have been almost 30 miles away, was less than 10 miles away. As the captain went into the chart room to check his position, he ordered hard to starboard rudder. Before the helmsman could answer the command, the ship ground to a halt. Total structural damage amounted to $2 million, and the ship lost $5 million in revenue while repairs were completed. All the officers aboard Royal Majesty thought they had an accurate perception of their ship's position. Each of them attested to the reliability of the ship's automated navigation system. It had worked properly for the 3 years it had been in service. Although it had occasional minor malfunctions, the system had sufficient alarms so that the crew could detect and correct or allow for any errors. The ship's officers had no reason to doubt this fully integrated system. It had proved itself to be an accurate and useful tool that would tell them when it failed. Besides, they continued to use the traditional method of plotting positions on a paper chart at least once per hour in order to the electronic map/GPS display. As the ship prepared to sail from Bermuda, the automated system was checked and found to be operating normally. None of them realized that, shortly after their departure, the connection between the GPS antenna and the GPS receiver was severed. When that GPS defaulted to a dead reckoning mode, displaying positions based solely on inputs from the gyro compass and the speed logs. The GPS display showed that it was giving dead reckoning rather than actual positions, but none of the officers noticed those displays. Thus, they all assumed that the GPS display position in satellite fixes, and, when they plotted them on their paper chart, the positions coordinated perfectly with the electronic map display. At least 30 times between the ship's departure from Bermuda and its grounding off Nantucket, some one of the officers had plotted the ship's position on a paper chart. Had any others compared any one of those GPS positions with the Loran positions, they would have found an ambiguity between Loran and GPS. That discovered discrepancy could have led them to the fact that the ship was consistently being set to the west on its northbound voyage. When the ship finally grounded, the Loran set showed the ship's position accurately. Furthermore, because the paper and electronic positions were matching perfectly, Royal Majesty's chief mate had good reason to believe he had sighted buoy BA on time and in the right position. He didn't see the lettering on the buoy because of the glare, but because what he saw matched with what he expected to see. He reported to his captain that he had seen the buoy when what he had seen was a buoy. In this case, it is probably understandable, but, nonetheless, he apparently did not question himself sufficiently about exactly what it was he had seen. His watch relief, the second mate, carried this automated navigation system one step further. Even though he had seen these same buoys on this same route both visually and on radar on earlier voyages, when he failed to sight buoy BB on this voyage, he chose to believe the GPS. Why he then chose to lie to his captain and say he had sighted the buoy when he had seen nothing is something only he knows. The second mate sealed his ship's fate when he failed to resolve 3 instances of ambiguity. There should have been no lights off Royal Majesty's port side. A lookout reported a light on the port side. The second mate sailed on. 2 lookouts then reported more light side. The second mate sailed on. A lookout reported blue and white water dead ahead where there should only have been a darkened ocean. The second mate sailed on. Then the second mate and his ship ground to a stop. If the second mate had shifted his radar from the 6-mile to the 12-mile scale when the lights were reported, he would have seen Nantucket and known something was terribly wrong. If the second mate had slowed to figure out what the blue and white water was, the captain might have come to the bridge and successfully resolved the problem. If the second mate had told the captain the truth, that he had not seen buoy BB, the captain might have started to ask the questions that would have corrected the ship's track. But the second mate had sailed on. The foundation for situational awareness and voyage monitoring is planning and standardized procedures. Plans and procedures give us something to monitor. They give us a standard by which to measure. Of course, after that, the plans and procedures must be executed and monitored effectively by the entire navigation team. If they are not, then no monitoring, or at best poor monitoring, is going to occur. Thus, the entire BRM concept is built up from voyage planning to standardized procedures to situational awareness. However, there are 3 impediments to situational awareness: stress, complacency, and distraction, that are so significant they deserve separate examination.